Good morning, everyone. Thanks for having me. I thought I give you a little bit of insight what we do in industry when it comes to AI and trying to demystifying this. I grew up in the mobile industry, working for a company called Nokia. You remember Nokia? Yes. We were building these things that you held next to your ears, billions of them, connecting people. And believe it or not, 30 years ago or so, it was really expensive to connect a thing. Yeah, it cost thousands of dollars. But then came what we call the mobile revolution with these systems on chips. So you can have compute and storage and communication and sensing in a very small yet affordable package. And now you can literally connect everything, every chair, for pennies. And with that is the ability to sense our environment, not only in industry, but everywhere else in a way we never could before. And if you have billions of assets sensing and giving you data, you get a lot of data. And if you have a lot of data, you need a place where to store and make sense out of this. And therefore, you need the biggest compute and storage, and that's the cloud. And then I moved a few years back to Microsoft and AWS, where I had the privilege to build what was called the non-IT services, which are now powering almost everything. And there I also learned the power of AI when it comes to you have a lot of data, but how do you make sense of this? Superhuman sense. And I also understood that the biggest impact of this is not necessarily consumer, but it's an industry. And that's when I moved 4 years back to Siemens, and now leading technology and research and development for all of our products. And you might ask, why industry? I mean, industry is everywhere. It produces the chair you're sitting on, the clothes you're wearing, the food you eat, the cars you're driving, the mobiles that you work and play with, the vaccines you got, hopefully, a few years back. Gives what, 1/3 of GDP is industry? So it's hugely important and touches every human being on this planet. However, there's also some things that are not so good in industry. It's our scorecard. When you look at it, industry produces roughly 1/3 of all CO2. We just talked about what CO2 means. We produce and we consume a little bit more than 1/3 of all energy on that planet. And we have a lousy recycling rate. There's almost nothing that is recycled today. And if that were not good enough with climate, I don't want to spend any time to talk about conflicts. It's horrible currently what's happening, but you understand what that does to our political environment and also to our supply chains. There's a ton which impacts how we do business in the world. And then there were always competition. And a few things that happen currently, because we were saying, is there's a shortage of labor, not because there's not enough people on that planet, but a lot of the work that you do in industry, people just don't want to do. Young kids, I have 3 of them. They're, of course, all adults already, but they don't want to go into a factory and work in a factory. They all want to do something on the internet. So that means the shortage is there. And the funny thing is, in the past, in industry, it was always never change a running system. Just keep it running. So keep it all stable. But in an ever-changing world where nothing keeps stable and everything is disrupted, it becomes much more important not to save a little bit of money in industry, but to become fast. Fast to adapt, really fast and be in flexibility. As my former boss said, speed disproportionately matters. So how do you accelerate industry? Industry which is very slow, it's physical assets based, and the answer is a very simple one, is you need to go digital. You need to try to digitize everything you can do in industry. Today, where we are the IAA outside, all these cars, you know how you build cars? You need to get iron ore and aluminum and God knows what else. You try to build them in models, you throw them against the wall, you see how they work well or not, and then you do it again. That takes a lot of time and resources. You can simulate all of this today. And not just one crash test, but 1,000, 1,000,000, 1 billion if you wanted. It's just the amount of compute and data that you create. And that means you can be superhuman fast and much better than just doing trial and error to improve the scorecards and the flexibility. And the next thing is, if you want to do that, you don't only have to do try and error, you could put some intelligence into this, and that is what we call AI. So it's more or less speed of software on steroids. It's the doping for software. And I want you to remember that. Now a little discourse. Netflix. 20 or so years ago, 2006, they put out a challenge. Netflix lives that you sit in front of the screen and watch one movie after the other. So you always get a recommendation. You might like this movie. And they have a recommender engine called Cinematch. And 2006, they went out and put a challenge in saying is, if somebody beats our algorithm by 10%, they get $1 million. And what they did, they published data of roughly 500,000 consumers, and 18,000 of the movies they had were rated by those consumers. And they were saying is, if you can predict what a consumer would rate a movie they have not seen correctly, then you're part of this challenge. And this challenge created a really big advancement in computer science, recommender systems, and other things which we use now every day. And but why do I talk to you about Netflix? Because there was another gentleman, Anand, which I don't know myself, but a good friend of mine who's head of research of Microsoft introduced me to him. What his work was doing, he was a PhD student and teaching at Stanford, and he had a computer science course, and he let his students participate in the challenge. And there was this one team which had a very fancy algorithm and tried to figure out how to beat the Netflix algorithm. And there was this other team which did something very different. They had a very simple algorithm, but they had the idea saying is, wait a minute, we get all of this data from Netflix, but there's this other thing called the Internet Movie Database, where there are much more movies with much more ratings. Let's this in addition to try to figure out what's the result. And guess what? Which of the two was much better than the other? So in that more or less comes what I always call the first law of computer science and AI is bigger data beats better algorithm. And it was not just Anand. Google, you all know Google. Use Google and search. And Peter Norvig, who was the chief scientist of them, he always said, our PageRank algorithm is not better. We don't have better algorithmic. We just have much more data because their trick was, instead of just crawling the web of the content, they said, let's look at other data, like the hypertext and anchor text. So that means you have much more data to train your data, so bigger data beats better algorithms, and better data beats even bigger data. So I want you to remember that when we talk about industry now. I show first a few cat pics, because you all know and used AI without knowing every day. Whatever you do on social media, or watching Netflix, or buying something with Amazon, my former employer, there is a lot of AI behind. It's all the recommendation, it's all to get you hooked onto their services. It's all in the digital world. If you go to industry, we go into the real world. Very different environment and very different challenges. And I thought I start with talking about money and then about some of the technology. So why is it so that in the internet we use AI everywhere? I mean, I make this now extremely simple, so bear with me. Saying is, the value of use case of, I don't know, getting the recommendation for the next cat video is most likely very small. But there are billions of people who like cats. So there's a really big user base. And funny enough, the amount of effort it requires to get cat pictures is very little, because we all upload our own pictures all the time. So if you have a very little value and very little effort, but a humongous customer base, yeah, you can make a lot of money. That's what's happening today. Now let's go into industry. Arguably, you could argue the value per use case must be bigger than just having a cat pic recommended. The problem is these systems and situations are very complex. So the user base is smaller. And here comes the other thing. The effort of acquiring data is much higher, because any company says, oh, it's my data. You don't have an internet of industrial data where everybody just freely publishes their data. So it's much more effort to get this. And if you put this all together, then of course the return is limited. So the magic of getting this all fueled is actually only two things. We need to figure out how do we get in industry to data fast and cheap. And we do make sure that many, many, many more people and customers can take benefit of this. And if you like, this is two of the key challenges in industrial AI is, how do I get to bigger and better data? How do I make industrial AI accessible to non-experts so that they can take benefit of this? And then there's a tiny little challenge in the physical world. And I just show you quickly what you can do for all three. So, access to data. One of the biggest problems is we all believe our data is ours when we in the professional world. In the private world, you all give it away for free. But in the professional world, we always say, no, it's mine. So how do you make sure that you get now data that is in these data silos actually connected? Because for AI, you need a lot of data. And if companies, even Siemens, thinks our data is a lot, it's nothing when we combine it with everybody else's data. So there are a few tricks that you can do, particularly when you do AI. One is that you don't have to get access to all of the data directly in learning. You can do what we call federated learning. The idea is that you can learn with your data, a little artifact, you can learn with your data, I don't know, and you don't share with me your data, you shared what you learned, which is this small little model. It's the outcome out of a training session for AI. And then you can have all of these individual models, combine them, and they prove to be very powerful afterwards. So there's a way to train without that I actually get access and know your data. There's another trick. You can do the same at scale where you say, it's called eyes-off or hands-off training. Siemens is using a lot of this when you go to AWS for Bedrock, for example, which is the biggest training engine in the world. Same idea, saying is, you have access to your data, you can upload and train it, but we cannot see it, cannot access it, and don't store it. So you do this while we have hands off. The only thing we'll see is the model, which is good for everybody. And then there's other things, because in industry, normally, you only know when something is good, because you're in a factory and it's always producing. You need a lot of data, sometimes also when it's bad, and if I don't get access, the good thing is I can simulate this. So if I know about physical things, how to simulate stuff, and Siemens is fortunately the leader in all of these simulation software worldwide, you can simulate all of this, what's called synthetic or simulation data. And again, the only limitation here is compute and storage, so you don't have to wait and go around. So there are technical advancements, federated learning, simulation, synthetic data, which can create very good and a lot of this good data, so bigger and better data. Now it comes to how do I make industrial AI easy to access? A year ago or 2 years ago, everybody and their brother realized AI is there, and that was because of the large language models. I mean, tech companies do this for 20 years. Everybody realized this with ChatGPT. So, and of course, these what we call co-pilots, where you can just speak language or text input, and the computer can do magic. Of course, you can also use in industry. We call this then industrial co-pilots. That is one great step forward. The only problem is machines don't speak English or Chinese or any other human language. The modalities, what you do that a machine needs to do, what a machine wants to do, is very different. And there are other ideas which are only possible, for example, when you use AI, which wasn't possible before. And I'm using the robotic example very simply. When you buy a robot and go in any industry, the cost of the robot is actually not the most expensive. It's the installation, engineering, and programming is up to twice the cost of a robot. So if your robot costs €1 million, you typically count another 2 million just to get it deployed and do what it shall do, because programming this is super complicated. Everything you need to predefine and have this done. With AI, this is very different. What you can now do is you don't train the robot at all in code. You just show it what to do. You just say, look, you shall do that. 3, 4, 5, 10 times. And if you do that with the new methodologies in AI, including transformer models, these robots then can do what is almost unthinkable. They adapt automatically and do their task. So instead of telling them what they shall do stepwise, you give them a notion what the end result shall be, and they can automatically adapt to the environment, not programmed. So the complex thing of engineering is calculated, and it's even statistically calculated using AI, making it very, very powerful. I just gave you some examples. By the way, there is no way in the world that you can program this deterministically. So having a robot doing these things, identifying t-shirts, putting it in, or that, you can't program. You can only do this with AI, but it makes it, on the other hand, so much more easy and accessible. Then there's the last thing. When you do a video game and you die, you click on reset. If you don't like something else, you start over. In the physical world, this is very different. If a robot hits a person, you can't click reset. So stuff in the physical world really matters. And that's a really, really different thing. But there are two things. You can first, of course, use the understanding of how a physical world actually functions, the physical, the chemical, any other mechanical knowledge, in order to have better predictions and guarantee certain results. That is what we call physics-informed AI. You can build models that don't hallucinate because with the knowledge of physics and the algorithmic behind and the calculus, you can restrict certain outcomes in the process of creating these statistical models, which is very important in physics-based AI and therefore also in industry. So it's one thing. By the way, that helps you also to make stuff much faster. You can simulate computational fluid dynamics. Again, I'm using a car example because of the IAA. So what is the best shape of a car? You can calculate this. It takes ages. You do this with AI, you can do this in milliseconds, almost, which is because you have these new models that are physics-informed. Now talk about the other thing. You need to make AI explainable. AI is a black box. It's typically a lot of neural networks, and they just do something because based on the training, it's the highest likelihood. So it's statistics. So you can't foresee the exact outcomes. So how do I make AI explainable? And there's a lot of research that we do and work in the world now that whenever there's a decision taken, that the supervision of a human can then say, okay, I understand why this decision was taken, even though it's based on statistic. Very, very important, particularly when you want to have trustworthy AI outputs. And last but not least, sometimes you also need to do something in hardware. You need specialized hardware that can be super fast in pre-calculating and has also some safety part included. So, with this, I only have one more thing. So I showed you technical solutions. What can you do to get more data and better data? Technical solutions and advancements, how can I make it more accessible? In technical solutions with very lot of knowledge, how do we make it safe and reliable and explainable? But there's one more thing. If you do all of this, particularly in industry, you need to understand that today industry is process-driven. I might know whether you've heard that the machine that controls the world or changed the world. So you always do the exact same thing. It's almost like a book. Do this step, then do that step, don't think, do this step, do that step. And you do this in the factory all the time. And if something goes wrong, nothing works. And that's why you have Kanban, stop the line, and so on and so forth. Well, it's established last millennium in the 50s. We still do automation, everything like this today. Actually, we are building almost all countries in processes like this. When you go software and AI, you became data-driven. And data-driven changes everything. Because everything that you knew, every habits you have, the way how you account, the way how you program, because you don't program anymore, is different. And that means the biggest prohibitor or change agent and also blocker is actually not technology. It's us. It's the human beings who need to learn new tricks, who have to learn and unlearn what worked well in the past is not working well in the future. I give you, again, a typical example, one in finance, because it's very simple. Finance likes to plan and want to know, what does it cost? What does it cost? What do I have to budget? You always have budget in companies. When you go into SaaS, which is a lot needed when you want to do what we do here, so software as a service, you pay on consumption. And now the finance guy says, yeah, what does it cost? Then the answer is, yeah, it depends on how much you use. How it depends on how much I use. I want to know how much it costs in a year. You're saying, you need to tell me how much you consume, then I can tell you the number. Finance can't handle that. So simple things like this, that nowadays there is pricing where companies literally are willing to pay much more just so that they know, I know that I will not pro more like this, instead of saying is, come on, learn a little bit out of SaaS, you pay a third, is insane, but it's true. Other thing is automation. In the factory, everybody will tell you, oh, you need to exactly know what happens every given time. Because if not, can't go into the factory. What I've shown you with the robots, you can't predict. It's statistics. And now how do you convince the factory saying is, you should install that? But yeah, but what if something doesn't work? I'm saying is, in your so-called deterministic systems, how often does something not work? Why do you need quality control? So that means we just don't accept that when these things changes, our notion of how things work need to happen. So it's really, really difficult for all of us to understand, to unlearn, and accept that the future most likely looks very, very, very different. Yeah, that's all I wanted to say to you and talk to you about. So if there's only one thing you remember, data matters, bigger data beats better algorithms. And if you don't participate and don't share your data, it's on you. Because when a revolution like this happens, the question is not, should I participate? The real question to ask is, what happens if I don't? With that, I wish you a great day here at DLD. And if you want to learn a little bit more, scan this code. Thank you very much.